All right, guys, let's go ahead and start our review for the Chapter 6 test. First of all, we'll just start off, go pretty quick through the first 20, because a lot of those are just definitions, and then we'll slow down when we get to some of the hard stuff. Okay, number one, it says an ionic compound results from the electrical attraction between large numbers of, and the answer is cations and anions, so the answer would be A. Number two, a nonpolar covalent bond is unlikely when two different atoms join because the atoms are likely to differ in electronegativities. Remember, we look at polar, nonpolar, and covalent. We look at them through electronegativities. Number three, bond length is decreased when two bonded atoms are at their minimum potential energy. Remember that everything bonds because they want to get rid of energy. Okay, number four, to draw a Lewis structure, it is not necessary to know, well, that would be bond energies, which would be B. Okay, we need to know which atoms are in the molecules because that's how we draw the symbols. We need to know the number of valence electrons for each atom, and we need to know the number of atoms in the molecule. All right, number five, it says multiple covalent bonds may form in molecules that contain carbon, nitrogen, or oxygen. Okay, we didn't really talk about this one, so you probably won't see that one on the test, but the answer is C. Number six, it says the principle that states that atoms tend to form compounds in which each atom has 8 electrons in its highest occupied energy level is called the octet rule. Remember, everything needs to be happy, everything needs to have 8. Okay, number seven, it says an example of a molecule that cannot be represented adequately by a single Lewis structure is, and the answer is ozone, which is C. And the reason why it can't is because ozone is what we call, it has a resonance structure, meaning that it can either look like this or it can look like this. Okay, and resonance structures means that you have either or. We could have the double bond over here or the double bond over there. It doesn't really matter. Number 8, it says the lattice energy is an indication of the, and that should be the strength in an ionic bond, so it would be A. Okay, guys, starting with the back. Number 9, it says a covalent compound in which bonded atoms have an unequal attraction for the shared electrons is called a polar covalent bond. Number 10, it says a molecule containing 2 atoms is called a diatomic molecule. Number 11, it says the degree to which bonding between atoms of 2 elements is ionic or covalent can be determined from the differences in electronegativities of the element. Number 12 says a neutral group of atoms held together by covalent bonds is called a molecule. And number 13 says the electron dot notation for hydrogen atom is very simple. It is H with 1 dot. Okay, number 15, a charged group of covalently bonded atoms is called a polyatomic ion. And let's go back to 14 because we missed that one. It says a shorthanded representation of a composition of a substance using atomic symbols and numerical subscripts is called a chemical formula. And we didn't talk a lot about that, so you might not see that one on the test. Number 16, it says a covalent bond between 2 atoms produced by the sharing of 2 pairs, and the main thing in that one is 2 pairs of electrons, is called a double bond. Number 17, the simplest collection of atoms to form which the formula of an ionic compound can be established is called a formula unit. Didn't talk a lot about that either. So, number 18, the energy required to break a chemical bond and form a neutral isolated atom is called bond energy. And number 19, it says a chemical bond that results from the attraction between metal atoms and the surrounding sea of electrons, and the main thing that we see there is sea of electrons. That is your metallic bond. And lastly, number 20, it says the property of being able to be drawn, pulled, or extruded through a small opening to produce a wire is called ductility. So we're able to pull it through, and that's a property of a metal that we've talked about. Okay guys, moving on to 21. It says use the VSEPR theory to predict the molecular shape of the following molecules. The first one we have is carbon dioxide. First thing we should see is our equation, and we should write down we have carbon and we have oxygen, and we have one carbon specifically because it doesn't have a subscript, so it's an understood one, and we have two oxygens, and we're going to go ahead and multiply those by their valence electrons. We look on the periodic table. Carbon is in group 14, so I know it has 4 valence electrons, and oxygen is in group 16, so it has 6 valence electrons, which give me a total of 1 times 4 is 4, 2 times 6 is 12. We have a total of 16. Okay, the next step, what we have to do is draw the Lewis structure. So we have carbon, and then we have our oxygens, and we're going to go ahead and bond those oxygens and carbon together, which remember each one of these bonds represents 2, so we have 1, 2, 3, 4. So now we are down to, we only have 12 electrons left. So we're going to go ahead and put those on the outside atoms first, meaning the oxygens. Okay, and I see I put 12 up, so now I'm down to 0. And I check and make sure, is everybody happy? And I see that oxygen has 8, it follows the octet rule, so does that oxygen, but I see that carbon does not, and carbon needs to be happy. So when I run out of electrons and I don't have an atom that has 8, I take 2 from one of the atoms and create a double bond. Now look, and I see that oxygen's still happy, but carbon still isn't happy. So I'm going to take 2 from the oxygen over here, and I am going to get another double bond. And I see that carbon now has 8, both the oxygens have 8, and I'm looking at the shape, and I see that I have a charge cloud here and a charge cloud there. Remember that it doesn't matter if it's a double or triple bond, it's still only one charge cloud. So I have 2 charge clouds. And do I have any dots around carbon? No. So 0 dots, meaning 0 lone pairs. And remember, I'm just looking at the center atom of carbon. So if I have 2 charge clouds and 0 lone pairs, I know that I am going to have a linear shape. So the shape of carbon dioxide is going to be linear, meaning in a straight line. All right, let's move on to number 22. We see we have methane. Remember, to find out the VSEPR shape, we start with the atoms. We have carbon and we have hydrogen. And we see that we have only 1 carbon and we have 4 hydrogens. Multiply them by their valence electrons. Carbon's in group 14, has 4. Hydrogen's in group 1, it has 1, which gives us a total of 1 times 4 is 4. 4 times 1 is 4, which gives us a total of 8. So we have 8 to work with in our molecule. So we go ahead and we set it up, put carbon in the middle, surround it by the 4 hydrogens. Remember, we always put carbon in the middle. We never put hydrogen in the middle. And then we put the least electronegative if we don't have carbon and there's not hydrogen there. So after this, we go ahead and we bond. Remember, those lines represent 2 apiece. So that was 4 of them. Took care of 8. Down to 0. So we check and see. Remember that hydrogen follows the duet rule, meaning it only needs 2. So each hydrogen's happy because it has that one line. Carbon follows the octet, and it has 8, so it's happy. So this is my Lewis structure. Now look at the charge clouds, and I say I have 1, 2, 3, 4 charge clouds, because remember, charge clouds are made up of the bonded electrons and the lone pairs. Okay, and I see that I have 1, 2, 3, 4 charge clouds. And do I have any dots around carbon? No, so I have 0 lone pairs. So if I look at my chart and I see I have 4 charge clouds, 0 lone pairs, I'm going to have a tetrahedral shape. Okay, and let's go ahead and just go ahead and skip number 23, and we'll move on to number 24. Draw the Lewis structure for the following substances in the space provided. So we're going to draw the Lewis structures, and the first one we're starting off with, we see that we have nitrogen, which is N2. It's a diatomic. So we're going to go ahead and start off. We have nitrogen, and we have 2 of them with 5 valence electrons apiece, which gives us a total of 10. So we set it up, and since there's only 2, there's not a central atom. So we have nitrogen bonded to nitrogen, and we go ahead, that bond took care of 2, so now we're down to 8. We go ahead and set it up, and we'll go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I am down to 0, and I see that this nitrogen's happy over here, but this nitrogen only has 4. So what do? We go ahead and we steal, move this down, steal those 2 electrons from right there and create a double bond. And we see that that nitrogen's still not happy, so what do we have to do? We have to steal 2 more electrons and create a triple bond up at the top. And we see that now both of the nitrogens are happy, and this would be the Lewis structure. Okay, moving on to number 25, we have HCl, which is hydrogen chloride. So we set it up, we have hydrogen, and we have chlorine, and we have 1 of each. And hydrogen has 1 valence electron, and chlorine is in group 17 and has 7 valence electrons, for a total of 8. So we go ahead and we set it up, and we will have hydrogen and chlorine. We don't have a central atom because we only have 2. Bond those guys, so now we are down to 6. Remember that hydrogen follows the duet rule, so it can't take any more. So we have 6 left, and we're just going to go ahead and give them to chlorine. We see that chlorine now has 8, hydrogen has 2, so they're both happy. We ran out of electrons. We're done. That's the Lewis structure. Moving on to number 25, we have carbon tetrachloride. So we have carbon, or sorry, not tetrachloride, tetraiodide, carbon and iodine. And we have 1 carbon and 4 iodines. And we know that carbon has 4 valence electrons, and iodine's in group 17, so it's 7, which gives us a total of 4 plus our 28 gives us 32. So we go ahead and we set it up with carbon in the middle and the iodines around it. Bond those together. That took care of 8, so now we are down to 24. We'll go ahead and we will start with the outside, put 6 on each of these iodines. And we see that now carbon has 8, iodine has, all of them have 8, so they're all stable with an octet, and that's our Lewis structure. Okay, moving on, we are moving on to our last one of water, which is H2O. So we're going to go ahead and start off with, we have hydrogen and oxygen. We have 2 hydrogens and 1 oxygen, 1 valence electron, and 6 valence electrons. So 2 plus 6 gives us 8. Okay, so we set it up and we put oxygen in the middle and hydrogen's coming off of it. Remember that hydrogen follows the duet rule, so it's already happy. We took care of 4, now we're down to 4. And we just put 4 around our oxygen, and we see that it now has 8, hydrogen has 2, it's happy, and that would be our Lewis structure. Okay guys, moving on, we're going to skip number 28 and 29. And moving on to 30 and 31. Now 30 says compare and contrast ionic bonding and covalent bonding. The main things that you need to know about ionic and covalent. Ionic is between a metal and a nonmetal. Covalent is between a nonmetal and a nonmetal. And ionic, you have the transferring of electrons. In covalent, you have the sharing of electrons. Okay, number 31, it says, why do most atoms form chemical bonds? And the main reason about that is they want to become stable. Okay, they want to have 8 valence electrons, and they